Welcome to Study Loop.
The ball's position as a function of time we modeled as initial velocity times time minus 1/2 times 9.8 times t squared. Now, trying to find the time it takes to go up and come back down, meaning that the y position hasn't changed at all, we set y equal to 0, equal to v initial times t minus 0.5 times 9.8 t squared. Setting these equal to each other, we get 0.5 times 9.8 times t is equal to v initial times t. Therefore, the initial velocity is 9.8 times t divided by 2. So we obviously have to find t. Now t we get from the entertainer. We know that the time it takes to run some certain distance, x, at a velocity v, is simply x over v. Our x in this case is there and back, and one way is 5.5 meters, if you read the problem carefully. Therefore, there and back is 11.0 meters. So 11.0 divided by 3.0, and let's see, you get 3.67 seconds until the ball returns to its original starting point. Therefore, the speed you need to throw it for this to happen is 9.8 times 3.67 divided by 2. Which gives 18.0 meters per second. Now the second part of this is how high above its initial position is the ball just as it reaches the table. For this one, since we're involving velocities and distances, and we're involving velocities because at the top of the throw, the final velocity, we can always say is 0 because it's either moving up or down at that point. Instantaneously, the velocity at the apex of the throw is 0. So we could use final velocity, or the velocity as a function of distance equation, which is the final velocity squared, the initial velocity, 2a times a, times yf minus y initial. In this case, yf minus y initial is simply going to be the height we're solving for, so we can just call our y initial 0. Therefore, we know that at the apex of the throw, we can say that that velocity is 0. And we know the initial velocity now. We know that that's 18.0. And the acceleration is obviously negative 9.81. And we're trying to find this yf, which is the maximum height that the ball hits just as she hits the table. Okay. So, or as she gets to the table while running, that hits it. So, setting this up, we get the the maximum height equal to 16.5 meters.